All right, so let's talk about something called a unit circle. A unit circle is basically a circle centered at the origin and with a radius of 1. So I'm going to draw that unit circle. Need an x and y axis. Have a radius of 1 all the way around. And we got a circle like this. Not the best circle I've ever drawn, but it'll work. Now, the unit circle is super useful when we're talking about trig because if I were to pick any point on the unit circle, say right there, and I call it x comma y, and then I were to draw an angle in standard position whose terminal side passes through that point. Up to this point, we've been building those reference triangles, the little right triangles that have the reference angle in them. So if I were to drop that perpendicular, I've got my right triangle. So if I look at this triangle that's formed, remember before we've been talking about the sides being x, y, and r. Well, in this case, the sides are x, it's the x value to get to that point, y, and the r this time, instead of being r, is going to be 1 because this is a circle of radius 1. Now, why is that significant? Well, here's why. If I look at the ratios that I have for the sine of an angle and the cosine of an angle, the sine of an angle, if you remember, was the y value over the r, and the cosine was the x value over the r. So since my r is 1 here, my sine is just going to be my y value, and my cosine is going to be my x value, which means any point on the unit circle, its coordinates are going to give you the value of the cosine of the angle whose terminal side passes through that point, and the sine of the angle whose terminal side passes through that point. So it's significant for us in that we can use this to build sort of a visual representation of what the special right triangle trig stuff we've been doing has been up to this point. Now, in the next screen, we're going to talk about how to do that. So, here is an unfilled unit circle. I know, it looks scary, but I want you to remember, first of all, what we just said, that there are points on this unit circle whose x values are cosine and whose y values are sine of angles that pass through it. So these points that you see around the exterior, those are going to be filled with cosine values and sine values, and we'll talk about that in a couple of minutes. But the first thing we really need to do is to get all the angle measures into this unit circle. Now, the unit circle is going to be basically a tool that you use to help memorize values of sine and cosine that you need to have in your head. And the ones that you need to have in your head are the ones that are built on quadrantal angles, the 0, 90, 180, 270, the ones that land on the axes, and the ones that are based on special right triangle reference angle trig. So like the 45, 45, 90, and the 30, 60, 90. All right, so let's go around and let's label the angles that are going to be on the unit circle. Any other angle that's not on the unit circle, you could still find a sine or cosine or tangent of it, but you would need to use a calculator to do so. These are going to be the only ones for right now that you would be expected to come up with exactly without a calculator. So we start at 0 degrees. The smallest reference angle I could have that would be in a special right triangle is a 30-degree angle, because remember it's 30, 60, 90, and 45, 45, 90. So the first angle I would hit would be the 30-degree angle. Then 45 is next biggest, and 60 is the biggest. When I reach my positive y-axis, that's 90. Let's go ahead and put all those quadrantals in. 90, 180, 270, and then I'm back at 360. Now, I need reference angles for every single one of these things that are coming on here. The reference angles are going to be 30, 45, and 60, and that's true all the way around. The reference angles will always be 30, 45, or 60. So really, in the second quadrant, it's going to be 180 minus that reference angle. And in the third quadrant, it's going to be 180 plus that reference angle. So if I look at this, 180 minus 30 is 150. 180 minus 45 is 135. 180 minus 60 is 120. Then if I move it to the third quadrant, 180 plus 30 is 210. 180 plus 45 is 225. And then 180 plus 60 is 240. And then the fourth quadrant, it's going to be 360 minus the reference angle, because remember the reference angles are built to the x-axis. So 360 minus 30 is 330. 360 minus 45 is 315. And 360 minus 60 is 300. So those are the degree measures in the unit circle. So what I'd like you to do now, we're going to actually go around and do the first quadrant together. We're going to convert these things into radians, and that's also going to be on the unit circle. So if I look at 0 degrees, that would be 0 radians. There's not much of a challenge there. But if I were trying to convert 30, keep in mind that the conversion factor for degrees to radians, I would multiply that by pi over 180. So the degrees would cancel out. And then I can simplify that fraction. And I get pi over 6. So that's the 30-degree angle. The 45-degree angle, same idea. 45 goes into 180 4 times, so that's pi over 4. And then the 60-degree angle would be pi over 3. 90 degrees would be pi over 2. And what I'd like you to do now is to pause the video and go ahead and convert the rest of the radians all the way around the circle. All right, so now, here's what they should look like. 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, and then 5 pi over 3, 7 pi over 4, and 11 pi over 6, and 2 pi. So now we've got all the angles filled in. In the next video, what we're going to do is go and fill in all the points around the circle.